Welcome to section 7.1, creating a class. In this lesson, we're finally diving into one of the most important ideas in Java, building your own custom classes. You will learn how to structure them, give them properties and behaviors, and use them in a meaningful way. By the end of this, you'll be able to write your own test main class, create and structure a Java class in your IDE, use conditionals and logic in your methods, and bring down a problem description into properties and behaviors, then turn those into code. Let's back up for a second. We've been playing with conditionals and loops, mostly inside the main method. That's great for practice, but now we're going to start doing things the object-oriented way. Object-oriented programming, OOP, is all about modeling real-world objects in code, giving them fields for data and methods for behavior. Everything in Java revolves around this. Once you get it, everything else clicks. In the exercise 1, play basic puzzle 6 and 7 in the Java puzzle ball game. The goal is get the ball to Duke by placing objects in the right spot. Watch what happens when you place something in a blue wheel. That's object behavior in action. A blue bumper is an object, and every instance of this object shares the same behavior for interacting with the ball. These behaviors may include deflection via triangle or the simple wall. When you place an icon on a blue bumper, every instance of that bumper gets a wall. The behavior is shared across all objects of that type. This is one of the benefits of OOP, consistency and reusability. Let's describe a blue bumper in code. Fields, properties, color, shape, exposition. Methods, behaviors, make a sound, flash, deflect a ball, get destroyed. These are the building blocks of a class. And yes, conditionals and loops totally belong inside methods too. You've practiced them in main, but your real logic should be in the methods of your class. The main method should just call them, not do all the work. Say a ball collides with a bumper. If it's a blade, the bumper should be destroyed. Otherwise, the ball gets deflected. That logic lives in a method like on collision with ball. The red bumper has this method for handling collisions. When this method is called, it checks to see if the ball is a blade. IsBlade is a Boolean property belonging to the ball class. If the ball is a blade, the bumper is destroyed. Otherwise, the ball is deflected. Getting destroyed and deflecting the ball are behaviors of the bumper. This is made possible with the getDestroyed and deflectBall methods. Now let's try modeling a savings account. You could write int balance equals 1000, string name equals Damien. That's fine for one account, but what if you have two? Int balance 1 equals 1000, string name 1 Damien, int balance 2 2000, string name 2 Bill. This quickly becomes messy. Now imagine 1000 accounts. Are you gonna copy and paste 1000 times? No. We need a better way. And that's where writing a full class comes in. This is the structure of a class. It contains the properties and behaviors of the objects. Here is what a class might look like. Now you can create as many accounts as you want from this template. Here is how you test it in a separate class. This is how we keep the main method clean. Just create objects and interact with them. In exercise 2, try yourself. Create a new object and write two classes. One is account test with the main method, and another one is checking account with balance and name fields. Then instantiate a checking account in main and assign it some values. Now, let's talk about scope. Fields can be accessed from any method inside the class, like system.out.println balance concatenated with balance value. No problem, fields are like global variables for the class. But method variables, they live and die in their method. For example, the field declared inside the deposit method cannot be accessed inside the bad method. This is why scope matters. If you want to interact with fields from outside the class, create an object and use the dot operator. When you call SA0001.deposit1000, the method receives 1000 as the parameter x. That value is now local to the method and can be used like any other variable. In exercise 3, write a withdraw method that takes a double as input, checks if the withdrawal is valid, warns if there is not enough balance, updates the balance and prints the new value if valid. Then test it in your account test. Sometimes you want to get a value from a method, like calculating interest. But variables inside a method don't exist outside. So how do you get them out? With a return statement. Here is how to return a value. Use the keyword return in combination with the value to be returned, such as return interest. Now, other classes can use this value. You can use it like this: SA0001.balance plus equals SA.calcInterest. That's way cleaner than hard coding a value like 0.83. This is the general format of a method. You've got a return type, method name, parameters, and the logic inside. Tip: don't cram logic into the main method. For example, SA0001.balance plus equals 1000, SA0001.balance plus equals SA.calcInterest. This is okay, but ideally that logic should be inside a method like apply monthly interest method. It keeps your main method lean and your program easier to manage. We'll dig into better practices in upcoming lessons. For now, focus on this. Look at a description of a thing like an account or bond. Break it down into properties and behaviors. Then write fields and methods to represent those. In exercise 4, create a new class to model a savings bond. It should have fields like name, balance, term, months remaining, and interest rate. The bond earns interest monthly and matures after 0 months. Use a tier method to set the interest rate based on the term. 0 to 11 months, 0.5%, 12 to 23 months, 1%, up to 60 months, 2.5%. When describing a savings bond, you may have thought of these fields and behaviors. You may have written your program like this. Translating the fields into data types is an easy exercise. The rate depends on the term. An if-else construct can be used to check the value of the term and assign the correct rate based on that term. It's also useful to check if the term is invalid. If this happens, the term is set to 0 to prevent goofy account behavior. Earning interest is the last behavior you need to translate into a method. An if-else statement is useful here as well. If there are months remaining in the term of the CD, interest is added, and one fewer month is remaining to earn interest. If there aren't any months remaining, the CD is mature and cannot earn interest. To summarize this lesson, you now know how to create your own class, add fields and methods, use conditionals to control behavior, return values, and translate real-world scenarios into Java code.